All right, guys, in this section we are looking at projectile motion, and so this is kind of a application of parametric equations. Parametric equations can be used to model nonlinear motion in a plane. All right, so let's say that we want to consider an object that's projected into the air at an angle theta with an initial speed v, and the object's parabolic path can be modeled with these parametric equations. All right, so again, we've got one for x and for y. And for the x parametric equation, you've got v times cosine of theta, t plus x0, and then y is equal to negative 1/2 gt squared plus v sine of theta times t plus y sub 0. Now, let's talk about each one of these parts. First of all, the x equation gives you the horizontal distance after a certain amount of time. The y equation gives you the vertical distance, or the height, after a certain amount of time. All right, so these are two separate equations now. And basically, when you look at this in rectangular form, right, it's typically height over time, right? So the x coordinate, or the x variable, represents time, and the y coordinate represents height. However, if you put it in parametric form, you can get a third variable, which is the horizontal distance. You can see how far the object actually traveled, instead of being just limited to height and time. All right, so that's the practicality of it. Now, just to make sure we understand what each part of the equation is, okay, so again, the x represents the horizontal distance the object has traveled. V is the initial speed, right? Theta is the angle at which it's launched. T is how much time, usually in seconds. And then this is the initial position at time 0. The position, or in other words, the vertical, horizontal distance of the object at time 0, which typically is going to be 0 in many cases. Now, on the y side of it, you've got negative 1 times negative 1/2 g. Now, g is the constant for gravity, and that's either 32 feet per second squared or 9.8 meters per second. Either one. Okay? All right, you guys are free to go. All right, so like I say, it can be in feet per second, or it can be meters per second. Yeah, just bring it up and put it at this first desk for me, if you don't mind. And t is still time. V is the initial velocity. Theta is the again, the angle, right? T is time. And again, this is the initial height at time 0, the height of the object at time 0. Y'all have a good day. All right. And again, this kind of the rest of this part just kind of goes over what we've already talked about. So when and some guidelines. So when the problem asks how far the object travels, we typically want to find when the ball hits the ground, like from the y equation, right? Okay, so let's see. Also, when it asks how long was the object in the air, we typically want to set the y equation equal to 0, since that's when the ball hits the ground. And when it asks for the maximum height of the object, then you want to find the vertex of the equation, right? Because that will actually give you the maximum height of the object. So again, if you want to see how far the object travels, we're talking about horizontal distance-wise, then you want to find when the ball hits the ground, right? Okay, from the y equation, and you can plug that back into the x equation to get the distance. How long was it in the air? You want to set the y equation to 0, because when it's on the ground at height 0, that'll tell you how many seconds, when you solve that for t, that it was in the air. And then, of course, the maximum height would be the vertex of that parabola. All right? So let's do a couple of examples here. So here's the first question. Okay, it says, in a pumpkin tossing contest, okay, a contestant won the catapult competition by using 2 telephone poles, rubber bands, power winch. Suppose the pumpkin was launched with an initial speed of 125 feet per second, okay, and at an angle of 45 degrees from an initial height of 25 feet. Okay, so our first task here is to write a set of parametric equations, okay, for the motion of the pumpkin, All right, so let's start with the x parametric equation. And again, here's the general form. So when we go to plug in, okay, we will follow this format. Okay, so again, we've got, and I'll go ahead and write this in first so I don't have to keep flipping back and forth. So it's v cosine theta close t plus x of 0. Okay? So now when we go to plug in, remember what v stands for. V is going to be your initial speed. And our initial speed is 125 feet per second. Okay? So 125 cosine theta. We can put in our theta because we know our angle. Our angle is going to be 45 degrees. So 45 will go here. Close that off. T will remain as a variable. And then now this is going to be the initial vertical distance. And the initial vertical distance here is going to be 0, right? At time 0, the vertical distance is going to be 0. So there is your x equation. Now the y equation, the general form is this, and I'm just writing this from the other page, negative 1/2 g t squared plus open v sine theta close t plus y sub 0. So now when we go to plug in here, this is going to be y minus, and we're going to say 1/2 times g. Now remember, g is a constant, and that constant can either be 32 feet per second or 9.8 meters per second. How do we know which one to use? The context of the problem. The initial velocity is 125 feet per second, so we want to keep that unit, right? So we'll stay with feet per second, which means I'm going to plug in 32 for g. So make sure that those units match. Whatever the unit of measure is for the initial velocity, then pick that unit of measure for gravity. So that's going to be 32 for here, and half of 32 is going to be 16. I'm going to go ahead and simplify that and make that 16 t squared plus, all right, initial velocity still 125, sine, my angle is still 45, close that off, t, and now my initial height, okay, remember, it's from an initial height of 25 feet, so it's being catapulted from 25 feet up in the air, right? So that's going to be plus 25. So it's not being catapulted from the ground, it's actually being catapulted from a height of 25 feet. Okay? So now we've got our two equations, so we've answered the first part of the problem. The second part asks us to use these equations now to find how far the pumpkin traveled. Okay, so we're going to have to find how far the pumpkin traveled, so we want this distance. That's the horizontal distance from the initial lodge point. And so I can figure that out from this equation, okay, if I know what time after how many seconds the pumpkin hit the ground. If I knew how many seconds after it was launched it hit the ground, I could plug this in here and find the horizontal distance to answer the question. So now we have to ask ourselves, well, how am I going to figure out how many seconds it took it to hit the ground? Well, that's where this equation comes in. Okay, so remember, if we want to know how long it was in the air, we want to set the y equation to 0, right? Because that's when the ball is going to be on the ground. So that's what we're going to do. So what we're going to do is we are going to graph the y equation. Y equals negative 16 t squared plus open 125 sine 45 close t plus 25. Okay, so we're going to graph this equation. We're going to graph this equation. All right. And when we do, we want to find the 0. All right, we want to find the 0 of this thing. Now, if you're going to be using Desmos as your calculator, go up here and make sure you're set to degrees, because it automatically defaults to radians. So when you're pulling the app up for the first time, what you will probably notice is that it's automatically set to radians. Set it back to degrees or you'll get the wrong answer here. So now we can plug this thing in. It's negative 16x squared plus, open a set of parentheses, we'll go 125 times sine of 45. Close that off and close it off again, and then that'll be x. I'm using x for my t here, and then we'll go plus 25. Okay, so from here I want to find this point where it actually goes back and hits the ground again, and then that will tell me, once it's on the ground, how many seconds after it was launched that'll actually go back and hit the ground again. And that's 5.794 seconds after it was launched. Remember how far it was launched at a height of 25 feet. All right, and notice that my graph reflects that as well. All right, so we can get everything kind of out here like this, how we want it, so we can actually see it. Okay, so again, 5.74. Okay, that is how many seconds after it was launched that it will hit the ground. Okay, so now that I know how many seconds it takes to hit the ground, I can plug that t in now, that number of seconds, for my x equation, which, remember, gives me the horizontal distance that the thing traveled. And so now into the x equation, x equals 125 cosine of 45, close, times 5.794, and once I multiply that out, I will know how far the pumpkin traveled. And so we'll take this now and we'll plug it back in, and we'll go 125 cosine 45 times 5.794, and we can see that the pumpkin traveled 512.12 feet. 512.12 feet. That is how far it traveled. Okay. All right, so there's one more problem that we need to look at. It says a projectile is fired with an initial velocity of 400 feet per second at an angle of 45 degrees with the horizontal. How many seconds will the projectile strike the ground? The parametric equations for the path of the projectile are here. So the equations are given to us this time. And the question is, in how many seconds will it strike the ground? After how many seconds? So what we need to do is we need to take this y equation, right? So I need to graph this and find the 0. And then that would answer the question. So let's take it and plug it in. So we've got 400 sine of 45. Close that off. Put my x out here. Minus 16x squared. All right, so that's the 0 that we need to find. And so I'm going to bring this out here and graph that point. And I need to make sure that this is 16 and not 6, so that makes a difference. Type that in wrong at first. All right. So now this is going to be the number of seconds that it takes to hit the ground. So my t is going to be equal to 17.678. All right. So that's how many seconds after it's launched that it actually goes through and hits the ground. All right. So from here now, what we can do is we could take this, and so that's the answer to the question. It just said, in how many seconds will it strike the ground? 17.678. Okay. And if there was a follow-up question like, okay, how far did it go in that amount of time? What was the horizontal distance? We could plug it into the other equation. X equals 400 cosine 45 times 17.678. And we'll go back into our calculator now to see what that would be equal to. So I'll go 400 times cosine of 45 times 17.678, and so that we can see now that our distance is roughly 5,000 feet. All right, here you go.